Okay, sir, you can.
Now this is a crankshaft from a locomotive in the railways. It's not the conventional type where the bearings are supported in white metal bearings and they are assembled in two halves. This has roller bearings, so which are accommodated in this large roller, and the whole unit is pushed in from one side of the crankcase, and then it fits into the roller bearing housing. So the opening in the crankcase is a very large diameter one and is known as the tunnel crankshaft. Main advantage, of course, is that it lasts a long time, much lower friction. And there is one motor car which uses roller bearings, which is upstairs. It's called a built-up crankshaft.
And
But
this is still in use?
it was. I don't know whether it's in use now. I think it's a German design.
Yes. And do you think that, applications, it's only in locomotives?
Well, it was used in locomotives, and the built-up crankshaft is used in a car.
Yes.
I think it was in the DKW car, if I remember right now. My memory is a bit unreliable. But this particular design of locomotive used this bearing.
Yes. And it's originated from Germany?
Germany, yeah.
Yes.
We had some German locomotives here which were diesel hydraulic.
Right.
I think it's from one of those.
Right.
This is a Ferguson tractor which was once very widely used in this country, and what we have done is to section the tractor transmission system. We have cut off the engine crankshaft and put a pulley here so that it can be driven from outside at very low speed. I think it's 24 revolutions per minute, very slowly. And it's very high gear reduction. And one of the safety devices here is that when it's plowing a field, if it gets stuck in a rock, the tractor can be lifted up so that it doesn't do any damage to the driving system. So that's a safety device, I think, that's here. Apart from that, there isn't very much to talk about.
Yeah, you have two gear levers, I suppose.
Yeah. I can't tell you that. I'm not, I've forgotten when you're looking what it's used for.
Right. And the safety device working out of,
It's a mechanical device.
Yes, a mechanical device.
If it hits a rock, you
Yes.
can't move, it lifts
automatically
lifts it up,
Right.
and then the tractor can move on.
Right.
Now we find a lot of broken crankshafts,
Yeah, we know.
rear axles from agriculture department vehicles, mostly jeeps. They get stuck in the mud,
Yes.
so they raise the engine and it breaks at the differential
Yes.
where the shaft is weaker than the rest of the shaft. So it's a common problem.
Okay.
Well, this is a crankshaft box, and it's very closely connected with the work we do in the third year, or we used to do in the third year. The firing order and the relative magnitudes of the outer balance force and outer balance couple. This is single cylinder, 2 cylinders, 3 cylinders, 4 and 6. A German visitor who came here saw this and he told me that there was a German car with 5 cylinders, but I have not seen that. So the diagrams given in the textbooks, like green stereo machines, can be supplemented by actually seeing these crankshafts and why the firing orders are variable. in order to produce higher or lower outer bands couples and outer bands forces. These are the main components, piston. The shape of the piston head is very important to ensure as much combustion of the fuel as possible. You can see different types of cylinder heads are used. Those are connecting rods, and that's all.
Yeah, all these out from where you get this? If
I have got them from government departments.
Yeah, these are all from light vehicles, or
Oh yes, actually yes, it's government department condemned vehicles.
Yes, and 5-cylinder one.
That one, it seems, is a car in Germany, but I have not seen it. This German visitor
Nowadays
told
not
me.
in use, maybe.
Probably may not be in use.
Yeah, the other ones which are right. 6-cylinder one?
Oh, 6-cylinder is very common one. Lorries,
Yes.
4-cylinder in cars,
Yes.
3 cylinders in some cars.
Right,
Now we
yes.
have 3 cylinders. There are cars with 2 cylinders. Single
Yes.
cylinder engines are used in industry, various purposes, light vehicles, petrol engines.
Yes. Okay.
This is the engine of an ordinary Volkswagen car. There are 4 cylinders laid out in a flat layout. But the important thing is that these axes are parallel but not concurrent. The cylinder axes move along parallel lines, but they are not concurrent as in some designs. That is the special feature of this Volkswagen engine. And apart from that, of course, it's an air-cooled engine. One of the first motor cars which were fixed at the back of the car and had air cooling, because the man who designed the Volkswagen engine was an aero engine designer, and he had a liking for air-cooled diesel engines. So a blower sends the air over the cylinder and keeps it cool. There's no water.
Right. But nowadays, modern Beetle cars, I think it's now these air cool systems used.
It's only in the Beetle. I don't think any other car uses
Right.
it. Of course, the penalty is that it's much more noisy.
Right.
The Beetle is a noisy
Yes,
car.
sir. Yes.
But because its engine is at the back,
Yeah.
you don't so much hear it.
Yeah, but the outsiders here.
The outsiders hear it, yes. That's the main difference.
Even the new car, the modern design Beetle, I think it's water cooled.
Water cooled, is it?
Yes.
The idea didn't catch on, but I saw on the TV the other day they have at last ended production of the Volkswagen Beetle. And they have produced 22 million Beetles so far.
Right.
No other car has gone into such large
Right.
figures. Now the Morris 1000, about 1.5 million, that was all.
So why this air cooled engines or this system is not used now in maybe
One thing is the
what
noise.
the
Noise
Right.
is one of the factors.
Right. Okay.
Now if you take a piece of chalk and give it a pure torsion, it fails at 45 degrees. That's the section at which the stress is maximum. Now we have an identical situation here. This is a large crankshaft which was on a fisheries department trawler, and I was told that there was a clutch somewhere there. So every time the clutch was engaged, there was a torsional impulse. So this area was getting a large torsional impulse, and it was also tapered. So it failed in fatigue after a number of cycles. And, you can see it's a 45-degree failure. It's an excellent example. This is also a fatigue failure from a lorry belonging to one of our companies in Colombo. One bearing was a little loose, so as the crankshaft was rotating, it was not only transmitting a torque, but also getting a certain amount of bending moment. So after many, many thousands of cycles, it broke across here. Here the higher stress around the oil hole led to the beginning of a fatigue failure. The highly stressed areas are the ones which are most susceptible to fatigue cracks. So here it's across the oil hole that the fatigue crack had developed after maybe so many tens of thousands of cycles. This shaft came from a tea factory, and it was part of the tea manufacturing system. It seems that one bearing seized and the shaft couldn't move. So before they could switch off the engine, the shaft had been twisted into the plastic range. You can see it is slightly
It's deformed.
deformed. It didn't break, but it has gone into plastic deformation. So in that sense, it's an interesting exhibit.
Maybe then it has developed another out of balance force. How did they stop the machine?
Knock off the
Yes,
electrical.
no, I mean, how did they find out? It's maybe.
No,
must have
one
given
end of the
a-
shaft stopped moving,
Right.
so they switched off the electric motor. Before it could stop, it had twisted.
Gone to plastic.
This came from Colombo Commercial Company.
Saw
Surya
this,
sent it to
yes.
me, and it's a shaft failure. It may be fatigue, I'm not sure. I can't say. This is a part of a shaft from the tire corporation. It was driving a very large electric motor, was driving some part of equipment. And there's a keyway here, very large keyway, which means higher stress
Yes.
around this area. So when it failed at the highly stressed area. This is the torsion bar of a Morris motor car, like mine. And it serves the same purpose as a spring. So when it's twisted, it provides torsional flexibility. And this one failed after many, many cycles. And you can see it's also 45 degrees.
Yes, it's a classical one.
It's a
Not
classical
like
one.
this.
This is an interesting failure. It came from a government department where there was a van with a four-cylinder engine. It seems that some water had leaked through the gasket into two of the cylinders.
Right.
The other two were perfectly all right. The driver wouldn't have known anything. He started it. Two cylinders fired, while the other two were compressing water.
Right.
And when you
Without
compress
that,
water,
yes.
so you can see the two connecting rods are buckled.
Right.
Now these two rear axles came from the agriculture department. Very often their vehicles go into mud. Then to extricate themselves, they raise the engine and put plenty of power. And the weakest part of the axle is where it goes into the differential.
Yes.
So the shaft is weak here, so it has failed. The agriculture department used to have so many of these failed shafts, all failing at the differential,
Right.
because the shaft is weaker at that point.
Right.
This is a camshaft which has failed in fatigue. There's no special reason why it failed there, but it has failed in fatigue. This came from a bus. That's a fatigue failure. This is a cast iron roller used in the CISIR, as they used to call it. It has a different name now. Sloan Institute for Scientific and Industrial Research. And they used to mix rubber and other compounds and roll it into sheets and then carry out experiments. As you can imagine, when there's change of section, there's a stress concentration. So it has failed here at the change of section. These are gear wheel failures in service. You know, when a gear wheel has been used for some time, it fails at those weak areas. And you can't predict them. That's a camshaft from a vehicle that came to the workshop, and it has failed there. Well, these are various types of failures. Here, of course, change of section. This was there.
Yes.
This is another torsion bar of a Nissan double cab. Once again, 45-degree failure. Another failure, pump just failed there. This is the main mast of a yacht, which is driven by wind, and it's a pleasure vessel, but of course it also has an engine. Emergency, if the wind is not there or if the mast fails, they could always use the engine to drive a propeller. Now this ship was 28 years old, and the height of the mast is 91 feet. And it was coming from Australia to Colombo, and somewhere 2/3 the way up it failed due to fatigue. This is the failure section.
Fatigue developed by wind force.
Yes, over the years, he is 28 years old, so it's a fairly old vessel. Then they put on the engine and brought it to Gaul Harbour, where the failed section was cut off, and then re-welded.
Shortened
The mast, yes. It was only about 1 foot short.
Right.
The mast is 91 feet, so 1 foot short is nothing. And off we went. This is a coil spring from a lorry. And after many years of use, it has failed in fatigue. And you can see it's 45 degrees. Standard classical failure.